welcome back. This is the final video in this series. I have everything now on the box here, everything ready to go on my wall. Here's the circuitry right here, and I have now a signal generator here, an integrator, and a couple buffers and amplifiers here. And I'm going to use my oscilloscope. I'm going to show you what the signals look like going from the input to the output. And then we'll take a look at the motor running, and then we'll take a look at the schematic and a little explanation there, and then that will be the final of this series. Stay tuned. I have the circuit turned on now, and we'll give a little detail using an oscilloscope and show the waveforms here. Okay, so the first stage here is a square wave generator, and that's going to generate a square wave. And let's take a look at that now. And that's a square wave, and it's a little bit rounded on the leading edge, but that's okay for this application. It's worked fine. It gives me about 4 volts peak, and it's about 20 kilohertz in frequency. And then that square wave now feeds into a wave shaping circuit, an integrator consisting of a capacitor and resistor. And when it goes through that integrator, it converts it to a wave like that. Now I have to increase the voltage waveform here on this because it attenuates the signal very much, but it converts a square wave now into a triangle wave. But the triangle wave now is only about 300 millivolts in amplitude. This circuit attenuates the square wave so much that we need some amplification. So now we take this back here on the voltage here. So it comes out like that, it's a triangle wave. And then we have to amplify that triangle wave. So now we take it through a power amplifier here. And we amplify that wave, and now we get it back to a 4 volt peak triangle wave. Now we feed that triangle wave into our Schmidt trigger circuit again, and we now end up with our pulse width modulated wave. Okay, so that's the waveforms of how they go from the input to the output to the circuit, and now we'll take a look at the motor and see how that's running now. I'm going to turn it on here. Here's I got the speed control here, a knob here for speed control, my indicator light for that there is feedback, and this is a fine adjust for the feedback. At high speeds I have to turn this back so the feedback's not so sensitive. This is a sensitivity control. I'll turn the switch on here, and we'll turn on slow here. And then turn it back. And we'll put on nice and slow here. And again, this red light indicates that there's feedback, so I'll put a little bit of a load on the motor here. And the light comes on. So that's indicating that there's feedback coming back to give me some torque control here. Okay, so now what we're going to do is we're going to take a look now. Now I have this temporary wired up. I have to put it on the wall here later on. Now we'll take a look at the schematic and see how that how the stages work. I got here now. I have a multi-vibrator here, a square wave multi-vibrator here, that puts out a 20 kilohertz square wave, about 4 volts peak. And like I said, that has to, now because there is the wave shaping integrator here, the triangle wave integrator here, this has a low impedance, and that could cause the output of the square wave generator to drop. So I had to put a buffer amplifier in the center here between the two to match. That's an emitter follower that matches the impedance, the high impedance of the generator to the low impedance of the integrator. The integrator now takes that square wave and converts it to a triangle wave. Now because of the heavy attenuation, the triangle wave, again, like I said, is about 300 millivolts. So we take it through the sawtooth amplifier that amplifies it back to 4 volts, and then that signal goes into the Schmidt trigger, and then this rest of the circuitry works as before. Now I have, instead of the feedback coming back to over here, I have it going back to the second transistor in the Schmidt trigger circuit. And what I do is I take it into there and cause that transistor to go into cutoff, and that allows the pulse width to modulate wider in that respect there. And that way there I'm not doing any kind of feedback into the original input like I did before. This just makes it work a lot better. Also on my lathe I have an extra potentiometer here. I have one on the circuit board here to get it rough adjust, and I have my fine adjustment 6K here on the lathe itself to give me that sensitivity for the feedback. And that's pretty much the schematic right there. That's how it works. And that pretty much concludes this whole series. And now I'll go ahead and put this on my wall, and I'll have my use of my lathe to work again with. Okay, thanks for watching. Bye.